think it works. In honor of you, I'm reverbing. In honor of you, I'm starting right away. Because it's a shorter class period and it's a full length assignment, so I'm starting in honor of you right away. First things first. You should already know this, and this factoring. You should already know it. If you don't, you need to get some help soon, because this is something that we are to know. We are to know this. This is what you are to know. All right. Hopefully, all of you, if not, you're going to need some help on this. Hopefully you know to factor this right here. We want to multiply to be 12 and add to be 8. Multiply 12 and add to be 8. So I'm writing down some things that multiply to be 12. 1 times 12, 2 times 6, 3 times 4. You already should know this. If you don't, you're going to need help. 6 and 2 meets both criteria, correct? 6 and 2. When there is a 1 out front of this, we can just jump to the answer of x plus 2 and x plus 6. If you knew that, say, I knew that. Good. If you don't, you are responsible to learn that. I would be glad to help you do that learning. I would be very glad to help you do it, but you're responsible to say, hey, I don't know that. All right, the next one is the one that's a little more difficult, but we've done it a lot. Multiplies to be 30, adds to be negative 13. I'm going to do it in order. 1 times 30, negative 1 times negative 30. They both multiply, they don't add. I'm just going to go up one bigger. Let me see. I'm going to switch this right now, right now. The problem should have said minus 10. I made a problem, it didn't work. Those that are noting, it should have been minus. So it needs to multiply to be negative 30 and add to be negative 13. I'll edit that out. Those of you who watch my videos know I don't edit any of them out. All right, so now 1 and negative 30, negative 1 and 30. It does the multiplying, it doesn't do the adding part. How about 2 and negative 15? Does that multiply to be negative 30? The answer is yes, it does. Does it add to be negative 13? Yes, it does. I'm going to use 2 and negative 15. All right, here we go. 3x squared. We replace the middle with these two numbers. Plus 2x minus 15x minus 10. Then we go to the factoring by grouping method in a little group of 2 and a little group of 2. X is in common, leaving a 3x plus 2. If there is a negative, you pull that out, and the number in fact is negative 5. Negative 15, negative 5 is 3. 10 divided by 5 is positive. Negative divided by negative is positive. We finish it up as x minus 5, 3x plus 2. Many of you already knew this. Many of you already know it. If you didn't, it is your responsibility to get this figured out. I would be glad to help you be the person that figures it out for you. Excellent. The next one, x squared minus 16. I was told by one student they would like that to be taught, sort of retaught, so I will reteach this just a little bit. There's a special thing when it is a square minus a square. And the special thing is this. Simply write down with a plus and a minus. It only works when it's a square minus a square. And you just x and x, and what times itself is 16? 4 and 4, just like that. Just like that.
Right. Why positive 4, negative 4?
Let's see. If I FOIL it back together first, outside, inside, last, do those two become a 0? They sure do. Awesome. Now, this is from my point of view. I have retaught all of these three things. You probably learned them during the pandemic or earlier. If not, they've been retaught. They've been retaught. So it's not unfair to you. The pandemic didn't destroy your education. All right, cool. This is the brand new one. This is the brand new one. And say yes or no, I'm requiring you to memorize the formula.
No.
The answer is no. And the formula we're going to use is a cubed minus b cubed, a minus b, a squared plus ab plus b squared. Okay. Wherever I see an a, in this one I'm going to put an x. Thank you. Wherever I see a b, I'm going to put a 27. So what times what times what? Same thing times same thing times same thing. Somebody don't say 2, don't say 4, say the number in between. 3. So a minus b becomes x minus 3. A squared becomes x squared plus ab plus x3. We like to write it 3x plus b squared plus 3 squared is 9. All right. New learning, and it's going to happen today. On a sheet of graph paper, this does not show up. It doesn't show up. It's called imaginary. It won't show up on the graph. Interesting. All right, here we go. I am going to write this problem over here so I don't forget it next hour. And we are going to graph the problem that is right here. First of all, I want us to look at the end behavior. Degree of 2 plus 2 plus 3, the degree is 2 plus 2 plus 3 is, those of you at home, it's as dull here as it sounds. 7, very good, very good. And by the way, without hitting the wall or your neighbor, the end behavior will look like what? It'll look like this. Very cool. All right. Do I think you should be able to factor x squared minus 4? Do I think you should? It becomes x plus 2, x minus 2. Turn to some kid near you and say, I knew that. All right, well done. Multiplies to be 7. I'm sorry, multiplies to be 6, adds to be 7. This is the problem I'm doing here. Let's see. Multiplies to be 6, adds to be 7. That's simply what and what? 6 and 1, thank you. There was some participation there. Cool. X cubed plus 8. Is that cubed rule? I erased the formula. Where I see an A, I put an X. Wherever I see a B, I'm going to put a what? Put a what? 2. So this becomes X plus 2. I'm doing the formula in my head. X squared minus 2X plus 4. Sometimes when there are difficult things, if you take little parts, it makes the whole thing easier. X squared minus 4, that little part, not too tough. If it is, get help from me. Factoring x squared plus 7x plus 6, multiply, not too tough. X cubed plus 8 would be tough if you haven't been taught it for a few days. If you need help, you need help. I'm going to rewrite this as, do I have 2x plus 2's? Say yep. X plus 2 squared. Nothing else matches up, so I have an x minus 2, an x plus 1, an x plus 6, x squared minus 2x plus 4. When I point to it, say, this shows up on the graph or this doesn't show up. This shows up. That won't show up on the graph. This one, using the non-mathematical terminology, 9th grade boy that I taught, this does what? It bumps and runs away. What about all of these ones? Zip on through. Here we go. It starts down low somewhere, ends up top somewhere. I put a dot at -2. That's going to bump and run away because it's opposite inside. +2. It's going to zip on through. Opposite. It's going to zip on through. Opposite. It's going to zip on through. These bottom things we can move if we need. I'm making my plan. Zip on through. Bump and run away. Zip on through, zip on through. This doesn't show up on the graph. The plan, let's execute the plan. Zip on through, bump and run away. Those of you that have been lucky enough to be present every day, is there anything new today? If you've been here every day, is there anything brand new today? Cool. I want you to use the class time well today. I want you to ask questions. I want this to be successful. Awesome. Dave, it's time. Dave, it is time. It's time to